Welcome to Ask and Learn.
All right, so this question here is asking us to see, let f of x equals x minus 3 to the negative 2. And we're being told to show that there is no value of c in 1, 4, such that f of 4 minus f of 1 equals f prime of c times 4 minus 1. And why does this not contradict the mean value theorem? So before we jump into this problem, I think it's very important to mention that this statement that it just kind of seemed like they just threw in right here is actually just the mean value theorem in a different form. It's just rewritten in a different way. So if you bring this 4 minus 1 underneath, it will just be f prime of c equals f of 4 minus f of 1 over 4 minus 1, which is simply the mean value theorem. So essentially, we're going to evaluate and find the c. That would be a good way to first start off this problem. So the first question would be to find the derivative of f of x. So f prime of x. Well, this is a chain rule problem. It would be best to apply the chain rule, but we're going to bring this negative 2 out to the front. And then we're going to subtract minus 2 minus 1, which gives us negative 3. And then we take the derivative of the inside, but since it's x, it will be times 1, so we don't write that. So this is simply our derivative right here. And we are also going to evaluate our values, f of 4 and f of 1. So f of 4 is just simply equal to 1 over 1 squared. Oh no, this is not right. Oh yes, it's 1 over 1 squared, so this will just come out to be 1. If you just do the math, 4 minus 3 is 1. Yeah, and then f of 1 comes out to be 1/4. And you can also check that by plugging in that value, and then you'll get 1/4 as well. And then, so what we're going to do now is plug in these values into our mean value theorem statement. So this will be 1 minus 1/4 equals, and then this is saying f prime of c, so all we do is take our derivative and substitute c in terms where there's written x. So this will be negative 2 times c minus 3 to the negative 3 times 4 minus 1, which is just 3. 1 minus 1/4 is simply 3/4. Oh, excuse me about this. Sorry about that. And then negative 2 times 3 is negative 6. And recall that any exponent raised to the negative power can be written underneath, so as a fraction. So this will come down to the denominator, so c minus 3 raised to the positive third power now. And now we can rewrite this. So we'll rewrite this. You can multiply c minus 3 on this side, and then 6 times 4 divided by 3. Negative 6 times 4 divided by 3 gives us negative 8. So this will be c minus 3 raised to the third power equal negative 8. And then now we simply take the cube root on both sides. And the cube root of negative 8 is negative 2. And then we add 3 to both sides. And that is equal to 1. However, there is a slight problem with this. I don't know if you've noticed, but the c value is not in the domain. It's not in the interval. Not domain, the interval. It is not in 1, 4, because when we are asked to evaluate a c in the open interval from 1 to 4. So that means we do not include the endpoints, which are x equals 1 and x equals 4. And we found a value of c equals 1. So this value of c is actually not allowed in our interval. And there's actually a really good reason why this is not allowed. The reason why is because if you look at the original function, f of x equals, what was it, x minus 3 to the negative 2. Let me make sure that's right. Yes, it is. Remember, this can be rewritten as 1 over x minus 3 squared. And you get, if you notice now that there's actually discontinuity in the domain of this function, and it occurs when the bottom equals 0. And the bottom equals 0 when x is equal to 3. Because if we plug in 3 right here, you get 3 minus 3 is 0, and 1 over 0 squared is 1 over 0, and 1 over 0 is undefined. And we are in the interval from 1 to 4, and 3 is included in 1 to 4. So there's actually a discontinuity in our function in the interval, in the open interval 1 to 4. So that means that the conditions required for the mean value theorem, continuity, is failed. And since this is failed, you can't, differentiability at x equals 3 also does not exist. So now you have both conditions of the mean value theorem failing with this function, and that explains why this value of c equals 1 does not fit in our interval. And that explains why that does not contradict the mean value theorem, because it doesn't even satisfy the condition for the mean value theorem. So that's why it's really important to check for whether the function even passes the conditions first before you even solve the problem.